This is Jim Green of JMR. This is the second in a series of how to program a mill part. The first series we got the part in from a SolidWorks model and oriented the part, established the zero for a vise, and added some stock to be realistic for our machining process. Next step will be to create toolpath. To create toolpath, we need two things. We need a tool and we need some sort of process. When we put those two together, we end up with an operation. And the operations are what create toolpath. So if I look at my CAD/CAM tools, which is called CAM, and I have a tool open, the first thing I want to do is say, what do I need to do? Now we could do all these one after the other after establishing what the tools are, or we can build the tools one at a time. Well, I know I need to face this, and I have a face mill. This is a small part, so I will use my 3-inch face mill. So the first thing I'll do is define the face mill. The important thing here is the width of the cutter and the radius of the cutter if we're going to use this in a roughing sense. Consistent with GibbsCAM, you can give names to these tools that would mean something. And those will stay with that tool forever. Also important to know is if you're going to use cutter comp registers, the first tool that you set up will carry on that an indication of your decomp registers, and then we'll increment basically from that value. So I'm going to use the value of D1 for the first one. So we have two ways to face mill this. One way would be to use a roughing cycle. And I can either double click or drag the roughing cycle down and put it on my process workbench. Process workbench can be modified to be smaller, as are the tools with your mouse. You can drag these up and down. This is a small part with very few tools, so I'm going to bring it up. And if I use a tool and a process together, it opens a panel automatically. This panel for face milling is a roughing panel, and it will use a face milling process. Now, depending on my material, I can look up a feed and speed, or I can go to the database and say, based on what I know about this particular stainless or steel, I can suggest a new surface feed and a new cut per inch per rev, and I can calculate the feeds and speeds on the fly. I can also just round these off to a value that I know works. Now this cut value is automatically filled in by Gibbs the first time, which is half the cutter length, and this is a face mill, so it's also including the 30 thousandths radius that I put on it. Now I can pick the type of toolpath I want and what corner I want to start on, and where I'm starting from and where I'm ending up in my clearance. Remember, my clearance, initial clearance, is set in the stock document right here. If we get a clamp in the way, we need to bump that up to a bigger value. In a vise, 100 thousandths might be okay. I have 100 thousandths here. So I'm going to say go ahead and face this. So I've got a tool, and I got a process, and I see it do it. Now GibbsCAM will always create 3 moves minimum on a face mill. So knowing that this is a small part and a 3-inch tool will actually face mill that part. So I'm going to change my process to a contour. In a contour process, I set the values by picking on a line. In this case, I don't have a line yet, so I'm going to create a line with my mouse. And my grid doesn't have to be too accurate, but I'm going to make it